Right. Good morning. Okay, we'll try and see if we can see my screen. So let me know once you can see my screen. Can you see my screen?
Yeah, we can see it. Hmm.
Okay. All right. So good morning. It's good to be here, and we're going to start the webinar. And to start with, it's going to be like a starting guide to start as a cloud network engineering. So I have a slide here. I'm going to share the slide um, after the session. So going to share it to the group. And as well, we have a community group whereby um, people can join. It's actually a WhatsApp group. So let's get started. Okay, so this is short info about me. Currently, I work as a network automation and cloud engineer, and it's been more than 5 years of experience in the field. I have Cisco certifications, AWS, GCP, Huawei, Calico, which is a Kubernetes networking. We're talking about container networking. And as well, I think I love reading and I watch football. And I'm a Liverpool fan. So, what are we discussing today? So, this is going to be the highlights of what we'll be discussing today. Why cloud networking, the traditional networking versus the cloud networking, and also guide to start. How do you start? What's the roadmap? And based on the survey, I think last week we pushed out a survey to check people's opinion about what's their provided, like the preferred cloud provider skills and all of that thing. So from the survey, 75% and above were taking AWS. So we're starting with AWS. We're going to break down the whole networking concept in AWS. And as well, we're going to have a very short demo, like a real world scenario demo. And I'm going to share the resources I used. Um, I call it my library. I'll share it with everyone here. And there's going to be a Q&A session whereby we ask questions. Okay, so can everyone hear me? Are we good?
Yeah, we can hear you. Yeah.
Yeah, we're good. Can you hear very well?
Yeah,
Loud
we
and clear.
can hear you. Yeah, we can hear
Okay,
you loud
all
and
right.
clear.
Good, good. So why cloud networking? So cloud networking is actually the backbone of cloud computing. For we all know that today there is a need for business growth. Companies are innovating faster, and uh, the era um, of this generative AI, artificial intelligence, people need to get to push things to production as soon as possible. They need a very good development environment to test out their features. They need all resources they can have within themselves. Maybe like 5, 10 years ago, when people started building data centers, we all know that big room, like racks, servers. We have all of those things there, whereby um you have to ship them. You have to ship them. So once you ship them, it takes like 2, 3 months, and after that, you need to start racking them one after the other and all. But with the era of cloud computing, is the on-demand delivery of IT resources over the internet with pay-as-you-go pricing. So actually, you can easily spin up a server from the corner of your room without even need to buy a server or buy a rack or buy routers or buy anything. So in that scenario, that's the era of cloud computing, and that's what people are actually into these days. That's going to be the, like more like the future of computing. So, and also the reason why we need cloud computing is that people are migrating their stuff from the private data center we all know to cloud, because there is no issue of the cooling, the security, the physical infrastructure, the generating concepts in terms of electricity, diesel, and all stuff of that. So you don't need them when you're on cloud, and they try to migrate their stuff. So within that migration part, you need like a cloud architect, a cloud network engineer to be able to feel the concept of what you're thing. And as well, people need cloud networking because they require like a kind of an isolated environment for their network, for their business. So so difference between traditional computing and cloud computing. So I've said it earlier, we have the on-prem, and which is the simple hardware. You see all those big servers, you see all those big routers, all those big firewalls, and you need cooling, you need electricity and all of that. But cloud, it's pay as you go pricing. You can start it anywhere from once you have to scale it in terms of maybe, for example, now, let's say example, Junior now. Junior can easily auto scale their resources. Maybe when they have this Black Friday, there is a kind of a surge in their demand. So those kind of scenarios are very easy using cloud infrastructure. You can easily scale out, scaling, and you pay as you go. And infrastructure as a code, a whole setup of a company, I can write a Terraform file for it. And at the end of the day, when I'm done, Terraform is destroyed and everything is gone. Terraform apply, I set up the infrastructure. Terraform destroyed, I destroyed everything once and for all. So so that's just like the difference between the traditional networking and cloud networking. So it's more your knowledge of traditional networking is still very useful when it comes to cloud networking, but they are kind of conceptualized in cloud networking because things are more on the virtualization scale. So for example, in your traditional networking, you may have switches, you may have routers, you have VLANs. For network engineers, they will understand VLANs and all of that. But in the cloud networking, you don't need all of that. Just need the basic IPv4, IPv4 addressing and stuff like that. So this is just the basic difference. So now let's go to the next slide. So for anyone trying to get started in cloud networking, I've tried to break all this down into like kind of levels, or it's kind of level. So from level 1 to the level 5, if you can take it step by step. There's an adage that says if you want to eat an elephant, you take it bit by bit. Right? You can't just take it as a whole. And there's a lot of resources outside there that might be like a burden to you. Like you see that moment of inertia, just feel overwhelmed, and at the end of the day, you won't be able to know the right resources to go after. So take it step by step. Don't rush. Give yourself the pace and the time. It's still something that is still fresh outside there. If you check the statistics, the people that are into cloud computing and all, it's still very of low percentage. So don't rush yourself. Just take your time. So starting with the first level, you need to understand the subnet address duration. What is the they call it subnetting. So you need to be able to understand what subnet means. How can you break a big subnet to small chunks of subnets? So I'm going to go deep dive when I come to AWS. But the first step is that you need to be able to understand what is an IP address. An IP address is actually like a numerical value that is that we use to that we use to assign to resource or entity over the internet. But they've actually made it easy that um, there's a DNS there. You don't need to know DNS. You don't need to cram IP address. But when you are starting as a cloud network engineer, you need to know what an IP address subnetting. So, for example, now if they give you a large subnet, I'll still go there in my next slide. But I'm just trying to let me try to add some people in. Just 1 second. Okay, I think I'll try to admit everyone and that's the first one. So I'm going to go deep dive to this subnet address location when I start when I'm going to start the AWS part. So the second part is the infrastructure. So the infrastructure part, it's how AWS or the cloud infrastructure are they able to partition their data centers. So for example, now we have about 20 something regions for AWS, and they are going fast now. So what's a region? A region is like a geographical location that you have an AWS presence, AWS data center. You have in South Africa over there. You have in US one. You have in Europe. You have in London. You have in Ireland and all stuff like that. So it's just like a data center, but a very big one. So inside this region, we have 2 or more availability zones. So for example, now in a region, for example, US is to 1. Let's say a region is US is to 1. So inside a region US is to 1, you can have more than, you need to note that more than. So the maximum number of AZ availability zone in a region is 2, like the minimum is 2. So you can have, there are some regions that have like 6 availability zone. And the reason for this availability zone, I'm going to explain it further when I get to the slide. So you need to understand, what does a region mean? So a region is like a physical location where AWS hosts their resources. Because all this cloud computing is somewhere there. It's not on the cloud up there. It's somewhere. So in a region, you have US is to 1, US West 1, EU West 1, EU West 2. Those guys are region. But inside the region, you have more than 2 availability zones. So you need to be able to get the concept. And the reason of this region is that because of disaster recovery, high availability. For example, now, if you put all your resources in a region, for example, you put it in EU West 1 region, and maybe there's a kind of this something that happened in California some months ago, like this wildfire. It happens, it happens just like that. Automatically, all your resources are gone. You can't get them again. So that's why another concept of it is the whole high availability in terms of placing your resources in different region, and as well latency. I can't be in Nigeria now. My customers are in Nigeria, and at the end of the day, I now want to deploy my resources in maybe in Sydney region or in China, something like that. So there will be latency. So probably people in Nigeria will use EU West 1, that's London, Ireland, or South Africa. So you need to be able to see and understand this region part so that you would have very low latency for your customers, for your product and services. And as well, data privacy. Data privacy. Some countries, they enforce that, okay, whenever you want to use a cloud, use it in this particular region. For example, China AWS region is specific for them, You can go ahead to read more about that. So that's let me just take a lot of time, but I'll still give a pictorial diagram like, going forward when I get to AWS. So the other part of it is understanding the VPC components. So you need to understand what a VPC is. So now let me break it down in a little bit. VPC is like is an isolated environment inside the cloud. I get to my point. It's just like your isolated environment inside the cloud. Now let's use a scenario. You have there's an estate. There's an estate. So now let's take AWS or GCP or Azure that as the estate. So inside the estate, we now have different bungalows, different buildings. I get to my point. So inside the estate, we have several bungalows, several buildings. So those bungalows, those buildings, individual of them are called your VPC. Why the whole estate is the AWS, the AWS cloud, the or anything or Azure or something or GCP or Oracle. But the individual bungalows inside that house are the VPC. So inside your VPC, you have the control over your house, your bungalow. You have the key to it. You are the one that the kind of people you want to that wants to enter your house. You are the one that provide inside furniture or furniture to your house, your bed, your bedroom, the way you partition your bungalow. It depends on you. Maybe you want this place to be your dining, this one to be your bedroom, this one to be storage room. So those inner partitions are your VPC components. I get to my point. So using that same scenario, so in that bungalow part, you have your sitting room, the public one that people can enter. Anybody coming can just sit down there. Anybody can come in. That's your public subnet. Your private subnet is maybe something like your bedroom. It's just people within your house, your people within your house that can have access to it. So anybody coming from outside cannot just barge into your bedroom like that. You need to stop them. So that's your private subnet. So you have your key, security door control systems. Those are kind of the security control lists, your network ACL, and your security groups. So all those, you have your route table that shows, okay, if you want to come to me, maybe like a directory in front of your door. If you want to see me or if you want to come to me, okay, this is where you pass, this is where you go, or something like that. So now looking in that kind of scenario will help you understand, okay, this is my public subnet. Who do I want to talk to my public subnet? For example, you have an application, a utility application. So anybody coming from the outside internet will land on your application, which is the front end. But your back end is going to be in your private, and your database is going to be on your private subnet, something that it's only your internal component to be able to reach them. So that's how that's just basically the component of a VPC. They call it virtual private cloud. AWS call it virtual private cloud. Azure call it VNet. VNet is still more the same thing. And I think GCP also call it VPC as well. So another thing I want to point out that if you can understand the fundamentals very well, you would be able to know any cloud infrastructure. Maybe your company is using Oracle, or your company is using I think there are a lot of cloud services these days, so it doesn't matter. So they will be able to understand what you want to do. Like you won't just be caught on our way. So it's very, very important to know the fundamentals. And this is this level one. And the fourth one is IAM. It's called Identity and Access Management. How you manage users. Okay, the kind of privilege. There's something they call the principle of least privilege, like giving a particular users the kind of the minimum amount of the minimum amount of permission required to do their job. For example, you can't just give a developer all your VPC access, or you can't just give maybe someone that's a database administrator all your application access. You need to just fine-tune it and give them the right access. So that's the fourth stage. You need to understand them. Or else an intern will just come to your network and delete everything. And there's nothing you can do. That's gone. Level two, so once you're able to finish level one very well, level two is in multi-VPC management. So for example, a scenario whereby you have a development VPC, a production VPC, a third-party VPC, or you still have, let's just do it like that. So that kind of scenario, you need something to manage those VPC together. That's where the management comes in. So for example, if you have one VPC or two VPC, maybe your production and your dev environments, or maybe let's say like your front end VPC, your back end VPC, you want them to talk together. You need to pair them. That's when you have one or two, three like that. So it's easier to pair. But when you have something more than two, three, four, you need to go into like maybe using transit gateway to manage multiple VPC. So that's when transit gateway comes in. So you need to be able to understand how to manage multiple VPC. I've seen companies that have about 20 VPC. It's an international company. Some have like 15 VPC. So you can't expect me to now start, okay, I'm adding the route from one route to another. It's tedious. So you need to, from in this management, to understand the transit gateway is actually a service in AWS. We'll get there as well. But all other cloud providers also have a service that they use to manage multiple VPC. I know most of us working in companies, we are aware of this, and we have multiple VPC. Maybe one to a third party, one to another. So the second point here is application gateways. This application gateway is still, it's especially if you are working on the application side, it's very, very important. How you expose your application, API, stuff like that. Maybe you want to expose your API, you want to expose an application, you want to put authorization on it. So it's also a very important part, especially if you are working with serverless microservices architecture, you need application gateway. So another part is the load balancer. How do you work with load balancer? The application, we have application load balancer for L7. We have layer 4 load balancer for network load balancer, the L3, L4. So the difference, which scenarios do they use them, and stuff like that. So you need to understand the load balancer parts. The level 3 is the domain name resolution. Let me explain this domain name in a very layman language. You have a phone book on your mobile phone. You have a number, maybe 081, 24, and all like that. And you have the name. You cannot memorize the name of your friends. You can't memorize the number. You need to use the phone book. Okay, I want to dial in Dozier. Okay, let me just search for Dozier and I call him. So that's what domain name is. Resolution is DNS. So www.google.com resolves to a particular IP, but you can't just cram the IP. So that's where DNS comes in. So it's also like a broad topic on itself. But how do you manage resolution on AWS, on GCP, on Azure? So that's another important part of it. You need to be able to
Hi,
manage the
Sulaiman.
resolution.
Sorry to interrupt. Hello,
Okay.
can you hear me?
I
Some
can hear
people
you.
are trying to join the call and they are dropping messages on
Okay.
the WhatsApp group.
Okay.
Is there a way you
Okay.
can make it so people can automatically join so we won't have to interrupt you?
Okay. Let me just try and fix that. Thank you for that. Let me just try and try to get that. It's a meeting invite. I'll just give you a moment. I'm just trying to edit the permission. Okay, sorry, I'm just trying to edit um meeting access. So okay, let me try to share my screen back again. Okay, can you confirm if you can hear me? Hello, is everyone there? Okay, all right. So okay, all right, okay. I think I'm getting reactions that you can all hear me. So the level 3 part is the DNS. I think I've explained DNS. So for example, if you have a URL internal to your cloud system, you want to expose it to the internet. So to external users, that's the DNS part, making it public. The DNS, and it has and also DNS has a lot of like TLD, they call it top level domain. So it's another scope for itself. Let us go inside down. But what I'm seeing that is that what I'm saying there is that the DNS, okay, there's something they call inbound DNS. Inbound DNS is, for example, maybe you have a connection from your cloud to your on-prem. So, and from your on-prem, which is on-prem means like your physical data center. Maybe like you have your data center in Obombo, maybe 1 year, or you have somewhere in rack center or something. So you want to connect to AWS or Azure. So there's a URL on AWS that you want to reach privately on Azure or on AWS. So you need to create like an inbound DNS resolver. So if it is the other way around, which is the reverse side, that's what we call an outbound DNS resolver. So maybe you want to use your on-prem AD to resolve AWS URLs or your resources. If you have a Docker and a microservice in a URL form, and you want to be able to use your AD to be able to resolve that guy. So DNS is a very important topic, especially when working with applications, microservices, and all of that. So that's the first thing in this level 3. So the second point, the hybrid connectivity. I don't know. Does anyone understand what this hybrid connectivity means? Can you give me an idea? I think I'm the one talking since, so I want it to be a little bit interactive.
Like maybe using multiple cloud providers.
Yes, that's very good. So yes, any other opinion as well?
Sorry, good morning. Maybe you have your cloud. Good
Good
morning.
morning.
Maybe you still have your on-prem infrastructures and your cloud infrastructures, and you need to communicate.
Okay. Thank you very much. Thank you, Jamio and Z. What's your name? The second person. I don't know.
Yeah, Bobola, Akinbobola.
Bobola. Okay, Bobola. Thank you for that. So, based on what they said, it's still the same thing. Hybrid, maybe yeah. Maybe when two or more things connect together with different sources, something like heterogeneous connection. So, for example, as I said earlier, you have your physical data center, maybe in your office, or you have a main one or somewhere. So, and you want to connect to AWS, so that's hybrid connectivity. So from your physical data center to on-prem, there's a common one which is the site-to-site VPN. Like, right? I think a lot of people knows that. A lot of people knows site-to-site VPN, maybe from your physical location to AWS, or from AWS to GCP, or from GCP to Azure. So the hybrid connectivity part also is an important part you need to also understand as well. So following that is content delivery. Anyone with idea of what content delivery means? Any any um any idea? Can anyone hear me?
Yes, we can hear you.
Yeah, so what does content delivery means? Like, does you don't need to be correct, so I just want it to be interactive. Like, what does it actually mean?
Um, just a simple overview, bringing the content closer to the user. Something
Okay,
like what
okay,
Netflix will do and have like CDNs in different availability zones or local zones so that the content will be closer to the end users.
okay, yeah. That's very good. That's a very good option. So I think someone also has his own hand up as well. Um, someone raised his hand. Do you
Yeah,
want to
from
say
what I
something?
understand, yeah, sure. So from what I
Okay,
understand, it's basically uh content can be anything from like your audio, videos, whatever, and it's just how that content reaches the end users that
okay,
we tend to focus on. So CDNs, like so anyone that basically hosts some form of digital media that end users can access.
okay. Yeah, thank you very much. Thank you, Mohammed and Emmanuel. So that's a very good option about CDN. So, for example, a good example is Netflix. Netflix uses CDN. So that's how, no matter how very low your latency is, even if you are using 2.5 edge, if you are not using 3G, you'll be able to use Netflix very well. So this content delivery network, it's as a technology or a device, it's actually a server, but it's optimized to do that kind of specific purpose. So there's Facebook CDN, Google also have their CDN, AWS have their CDN, and Netflix specifically built their CDN by themselves. So this CDN is just to bring the media, any content, maybe video, audio, live chats, what is Instagram and all of that. So just to bring it closer to your users. For example, now, there'll be a bias. For example, I'm an international company and all my subscribers are over the world. And I have my server just somewhere in Europe here. So people maybe people at Sydney or in Australia, they'll be having low latency coming over from Sydney down to Europe. So it's going to take a lot of low latency, and to cater for that, that's where the CDN comes in. So the last part in this level is the network firewall and the web application firewall. So it's an overview of how to secure your infrastructure on your cloud system. So you're also part of the stage or the things you need to be able to understand very well. In terms of maybe you want to whitelist particularly a, a particular maybe a particular country should not be able to access your resources, or you have some kind of a blacklisting process. So those can be done using the WAF, the web application firewall. So the last part is very important. It's very, very important. Monitoring, logging, observability. The first one is flow logs. It comes in handy in every VPC. AWS have it, Google have it, Azure also have it. It's very, very important. Flow logs, you won't know the importance of flow logs until you start having issues. If you have issues, you'll be able to understand the flow log. The flow log is going to give you the top parameters. What are the top parameters? Your source address, destination address, source port, destination port. Is it allowed or denied? Who requested for it? At which time? So it's going to give you all those important details. Is it accepted or is it denied? At which time? What triggered it? So flow logs is going to give you that robust features and observability as well, and the logging. That's your CloudWatch on AWS. And also there's a service, network reachability. We have it on AWS, and we also have it on Google and Azure as well. So you'll be able to note, for example, if you have like an hybrid connectivity from AWS to your data center. So for example, if there is a blockage on the way, you can use this reachability analyzer to analyze your package from end to end. So you actually know where it is dropping, where there's an issue, especially if you want to drop shoot. If time permits us, I will show you all of these things on the AWS console itself. The last one. Some people want to join. Let me try and add this one next. Okay, so the last one, which is the last level, based on my own guide, is microservices, kubernetes, networking. You would really appreciate these skills. For example, if your company is using microservices a lot, it's very, very important. The DevOps engineer basically knows, okay, they have an image, they pull it or push it from Docker, they use mchat on their Kubernetes cluster, and they spin it up. But in a Kubernetes cluster, how does it communicate? How does the controller manager connect to the etcd? From the etcd, how does it connect to the Kube API server? From Kube API server, how does it go to the Kube proxy in each node? So it's very, very important. So your Docker network, your container networking, have you ever think of how a containers or how container works? For example, you have a Docker image, you start running it. How does it connect to your host system? There's a Docker bridge in between those guys, like that acts like a VLAN. So once you spin up a Docker, you have a Docker on your laptop now. Automatically, you are going to have a Docker bridge. You can see Docker 0 or Docker something. That is your Docker bridge. So it's one that bridge the Docker network to your host network. And most of your traffic will be going out with your host IP address. And you can still configure your Docker network, your container network, to have their own networking aside. So it's also a very, very important knowledge to understand. How does container work together? Container A, container B. How does they talk to themselves? What's the high level or the low level between them? So if a Docker container, if an image that is running here cannot talk to another image running on another host, how do you troubleshoot? So things like that comes in the container networking. The cluster networking is Kubernetes. So Kubernetes I would say if you understand networking very well, you will really appreciate Kubernetes a lot because the Q proxy in each of the nodes, all of them is networking. It's just IP tables, network address translation, your kube service, from your cluster, which is your master node, where you have your etcd, your kube API server, and all of stuff of that. The communication around those components in your control plane is made up of the networking parts. So if you want to bootstrap an image into your cluster, you need to add some parameters and all. So those parameters are more like adding that node to your cluster in terms of the networking. So it's still the background. So you're like DevOps engineer, and you have this idea of this cluster networking. You'll be able to troubleshoot very well, especially if you expose a service, a load balancer service, and you are not getting traffic or it's not communicating to your ports. So you'll be able to check, okay, where is the NAT translation or the IP tables coming from, and you'll be able to troubleshoot it. So we also have some companies that manage this networking. So we have Calico, we have Senior, and we have Flannel. Some companies uses Flannel. I think some companies use Flannel, some also Calico. I've used Calico before, and I've used Flannel before, but I've actually not used Senior. So these guys is just to manage, instead of using the default Kubernetes networking CNI. So you can just use any of these guys to act as your CNI. CNI actually means container networking interface. You also have CSI, container storage interface, where you want to integrate your cluster or your container with storage. But the one we are talking about is networking. How do you expose your networking components within a cluster? So service networking, this one is specific to AWS, but I think Google has something like that. So if you want to do like the service to service communication on a cluster level, that's it on the service networking. But I think it's specified to AWS only for now. I'm not sure Azure has that kind of service to service connection. So from all of my explanation, I'm just trying to break down the levels of this cloud networking. How do you get started to the advanced level, like to the places where you'll be comfortable, because all these things are dependent on each other. You can't just start on level 5. You need, without knowing the basic ones, how the basic connectivity, the level 1, level 2, level 3, level 4. So I'm very sure most of us might be in level 1. Some might be in level 2, some might be in level 3, some might even be in level 5. So whichever way you still find yourself fitting, just try and know, okay, this is what I'm trying to gain knowledge with. And with the right resources, you'll be able to get there. And there's an interesting thing about knowledge. You won't appreciate it until you find yourself in a situation where you need it. That's when you need to appreciate, okay, wow, today is my day. Today is just my day. So you feel that kind of and that can be your talking points or your breakthrough point, that particular knowledge that you have. So that's why you just need to take it step by step. Don't feel the pressure. Don't just take it step by step. So this is I hope everyone is still here. Let me see some reactions to know we are still together.
Yes. Yeah, here.
Okay, all right. Okay, thank you very much. So this is the AWS networking. So now let's deep dive into AWS. So I'll try to over my mouse and show you each of those things. So this is the region, as I've said earlier, this is the region. You can see the region. You can see the region. We have the public subnet, we have the private subnet. So this region might be EU West 1, might be in Africa, might be in Sydney, might be in Europe. So let's say this one is US is 1. So you have your VPC inside this guy. You have your public subnet. You have your private subnet. So you have the transit gateway. This transit gateway is when we're talking about multi-VPC management, how you manage VPC. So this guy is just like a connectivity model that connects VPC together. You can connect more than 100 VPC together using this transit gateway. It's an interesting AWS service. Very interesting. So we have peering connection. This peering connection and transit gateway, they actually do the same thing. But transit gateway, the only difference is that peering connection is when you have 2 or 3. So you need to do it manually. But transit gateway, you don't need to manage them one after the other because the peering connection is not transitive. So for example, if you pair A and B together and you pair A and C together, does that mean B and C are connected? I want response. Do you understand my question?
Sorry, come again.
So my question is, you have a VPC A and VPC B, you pair them together, okay? And you have VPC A, you pair it to C. Does that mean B and C are connected?
They are not connected because it's not transitive.
Why? Exactly. So you need to do a pairing again with A and C. Do you understand? So pairing has to be on both sides. It has a formula like n into bracket n minus 1 divided by 2, something like that. So that's the bottleneck of pairing. So for example, if we have like 100, if we have like 15 or 10 connections, we'll be having more than 25 or 15 pairing connections, and that's a lot to manage. So that's where transit gateway comes in. You only need a connection from your VPC to your transit gateway. That's all. So transit gateway is transitive. And that's why we call it transit gateway, because it's transit. So you have the direct connect gateway. That's a physical connection from your AWS environment to your physical data center, the one you have in your office. That room that has a complete cooling system, that data center, or the one you have at Ogombo, or the one that you have at Rack Center. So the connection from those guys to AWS, I think Rack Center is the only direct connect partner for AWS in Nigeria that's now. I know the one is for Azure. Yes, Express Route Direct to Azure, yeah. But I think Rack Center is the only one whereby you have physical routers. You connect them, you put your cable and all of that, and you connect to your VPC straight up. So the reason why direct connect makes sense is because of the traffic, because of the bandwidth. It gives like 100, like 500 gigabits, 1 gig, and 500 Mbps, 1 gig, and all of that. So we have the direct connect gateway, and we have the VPN. Is that I'm saying that the side-to-side VPN from your on-prem to your cloud. So the difference between this guy and direct connect is that VPN, you can do it instantly. I can just do it the way we are talking now. We can do it as far as you have a public internet, just like side-to-side connection. So it's using public internet, but it's encrypted. It's encrypted. So that's the difference between the VPN, the transit gateway. So we also have so now let me now explain AWS VPC. As I've explained earlier, you can see that the region is US East 1. So that's our region that we have our VPC. So inside the region, we now have US East 1A and US East 1B. So these availability zones are like partitions inside the region. So, and the reason for this is because of high availability. So you can't just put all your resources in one availability zone. So you need to make it highly available, and that's one of the pillars of design So you need to make sure your application is highly available. So that's where we have this guy. So you can see that your public subnet is here, your private subnet is here, still the same thing here. So inside your VPC, now let me go to this VPC. Let me explain better. So as I've explained that the VPC is just like your bungalow inside an estate. So there are some things that helps communication, it protects your VPC, which you need to understand very well. The first one is you understand your public subnet and your private subnet. Private subnet is within you, is your bedroom, you and your kids and your family. It's within yourself. But public subnet, that is just like a sitting room. Anybody can come to this. Anybody that give access to, anybody that give access to can come and see you. So now, how do you give access to your visitor? How do you give access to people to come to your house? So which automatically means how do you secure your VPC? So in this instance, there is a shared responsibility model. There's a shared responsibility model on how AWS protect their site and how you protect your site. Now look at it in this way. Using that estate analogy, there's some security that your estate is going to be the one that will give you. And there are some security whereby you are the one that you're going to give yourself. You must do it. For example, the door of your house, who is expected to lock it? It's you, right? Your window, who is expected to lock it? It's you. Or maybe the fencing and all of that things like that. Maybe that's for your estate manager or something. So same thing goes to AWS as well. That's what they call the shared responsibility model. The door of your house, you need to lock it. You need to close your window. You don't need to on your burner. You don't need to expose your properties and something like that. It's your responsibility. But providing the basic infrastructure, the infrastructure level protection, that's AWS for you. So now let's go inside the VPC now. So this is your EC2 instance. There's something they call security group. Security group is what that protects you on the instance level. You have a server. EC2 instance is called a server. Just a server. So how do you protect the server? So you add a security group to it. The security group means that, okay, you want to come and meet me. If you come to my door, I need to give you access to come to my door. So it's stateful. So for example, now, maybe Jamie wants to come and meet me now. I need to give him access. And the security group is allow. You cannot deny, just allow. So once Jamie entered my house, I've given him the access. When he's going back, I don't need to give him access again. So that means it's stateful. So inbound calls will come in and they'll be able to go out. That's security group. So for example, now you have an application, your instance is hosting like a server, maybe you're running a Python application that is listening on port 80. So you need to create a security group that will allow incoming connection on that port 80. So anybody that is coming from outside, so they'll be able to access that particular port on your server, that security group. So you cannot deny, but you can only allow on security group. So that's why I said it is stateful. And it only occurs on the instance level. You attach it to your server. That's security group. But network ACL, it is applied on the subnet level. And it is stateless. What do you mean by stateless? For example, now, maybe when Johnny comes to my house, I've given him the security group to enter my sitting room. He can sit down, can access what he wants. But at the main entrance, there's a main entrance, he needs to tag in and tag out. He needs to click in and maybe like go with this card. If you want to go to your office, tag in and tag out, something like that. So he needs to do that when he's coming and when he's going out. That one is occurring at the outer level, which is the subnet level. So at that stage, that's the network ACL. So the network ACL is being applied on the subnet level, and you can allow or deny. So if both for incoming and outgoing, you need to whitelist it. Are you getting my point? Is it clear or it's confusing? I want your response. Hello, is everyone there?
Yeah, we can hear you, bro. I got lost along the
Okay.
issue.
Okay. Okay. Let me try. Where did it get lost? Where? I want to know where. At which point? At which point? At which point do you get lost? Let me know. Hello, are you there? Hello, can anyone hear me? I don't know. This is my
Yes, we
network.
can hear you. I think you had network.
The network is fine. Yeah. Maybe it's his network.
Okay, so at which point did you get lost? And were you able to I want to know so that I can try to come over again. I mean, is it back? Is it back? I want to know if it's back. Is it oh, if someone said it's not clear, get lost at a point. Aside from him, do you have anyone with do you understand? Can we- okay, come again on his stateless. Okay, all right. So now let me come again on the stateless and try to explain again. So as I've said, the stateless is let me use that when you want to tap in and tap out. The stateless, which is network ECL, it occurs only on the subnet level. You know, I told you that in your VPC, you need to create a subnet. You have the private subnet, you have the public subnet. So if you expose your application on a particular port, for example, now you expose your application on port 80. So if you want everybody on the internet, that's a default route 0.0.0.0 to able to access your server on your subnet, you need to allow that particular 0.0.0 on your ACL. But if you use AWS by default, everything is allowed by default on the network ACL. That's why when most people are starting with AWS, don't need to use this network ACL. But when you're working with organization, you need to implement some security approach to it. So in the scenario whereby you need to allow the network ACL, that's 0.0 to come in. And also, if you are also going out, you should be able to also communicate as well, both inbound and outbound. You need to make an allow on that guy. So that's where network ACL works. But just like if you want to tap in and tap out, that's how network ACL works. But the security group is stateful because it only allows inbound. You don't need to explicitly allow it when it's going back. Outbound, a security group is default. Can go outbound, any guy. But see, our network is here. As you are going in or you are coming out, you need to whitelist it. You need to be whitelisted. For security group, you need to specifically, security group, okay, just only on ports. You know, I've explained that it's on an instance level, on a port level. I think I'm going to do a quick session and I will show that on my AWS console. So I think, is it clear now? Okay, I think we can proceed. So we have the internet gateway. Internet gateway, let's see this guy as a means of calling people inside your apartment. Anybody to come inside your apartment. If there is no internet gateway in your VPC, you cannot go to the internet. You cannot reach the internet. So this guy just like your gateway to access internet. You know, maybe you have a router in your house, you have something. So something that makes you to connect to the outside public. That's your internet gateway. And you apply it to your VPC. You attach it to your VPC. So that's how the internet gateway works. The route table, that's where you have your routes and where you point it to. Your default route will point it to the internet gateway, stuff like that. So that's your route table is just, okay, if you are going to the internet, okay, point my traffic to the internet gateway. That's how the route table works. So we also have something we call the NAT gateway. The NAT gateway, I think I have the NAT gateway here. NAT gateway, for example, now you have your database. Database is actually in a private subnet. And private subnet are not allowed to communicate with the internet. Because you don't want to expose your database to the internet. Do you understand? So in that kind of scenario, you need internet. Maybe you want to update your database, maybe your SQL version, so you want to update it. So you might need a NAT gateway. So NAT gateway allows you to call the internet. It doesn't allow internet to call you. So it allows the database server to fetch that particular update. To fetch that particular update, and just 100%. I'll work well on this one. On this guy later. So the NAT gateway allows you to call the internet, but it doesn't allow the internet to call you. Let me come again. It's NAT gateway allows you to call the internet, to pull your updates, maybe to get your download your packages, your patch, and all of that thing. But someone on the internet cannot reach you via the NAT gateway. Via the NAT gateway. That's how the NAT gateway works. Okay. So let me go to the next slide. So your addressing type, you need to be able to understand your addressing. I said it is part of the first level to understand how addressing works on AWS. So ideally, this is a typical VPC address range. You have 172.30.0.0/16. So this guy, assuming is your VPC range. So you need to create a subnet. So that's why if you are planning your VPC range, you need to plan it in a way that it can scale. It can scale. So you can't just use a very small VPC range for your architecture. So you need to look at something very high, something like 16, 20. I think the minimum you can use on the AWS is I think is it 8 or 9 or something. Yeah, it's very, very much. You can see it in documentation. But when you are planning your design, you need to plan for something very high, maybe something like a 9, 10, 20, 16, but you can't go less than 24. I don't even advise you to use 24 for your VPC. I actually advise something like 16/20 for your VPC range if you want to design your architecture. So in your VPC range, so you start breaking it down into subnets. So typically there's a design strategy. The third octet here, which is this guy, some companies use it in a way that the third octet is going to be the public subnet. So if you have your third octet is 1, 3, 5 odd numbers, that means that it's a public subnet. Sometimes if your third octet is 2, 4, 6, even numbers like that, that's a private subnet, just like a design strategy, just for them to be able to look up things faster. So you can also do that in your own architecture as well, just to make things easier for you. So this guy, public subnet is /24. That's it has about 255 IP assigned. So that's why it still goes back to that subnetting. It's very, very important. So because it's only a subnetting class, that's why I'm not really trying to dive into it. So this 24 means that this particular subnet has about 255 assigned IP. But inside that 255, they are not the owner of everything. So AWS will take, the first one is the network address. Second one is for your VPC router, the gateway. The gateway in that subnet. These two guys are reserved, and the last one is the network broadcast. So if you want to assign any IP, maybe you have a server, so you can only assign from 1.4 to 1.254. Hello everyone, are you following?
Yes, sir.
It seems very quiet. Okay, so if you want to create a server, so sometimes AWS dynamically gives you the server IP sometimes, but you can never be assigned either of these guys at all. So that's why you need to be curious. Why did I create a server and I can't get 1.1? I can't get 1.2. So you need to be curious sometimes. Sometimes you use VPC, you need to be wondering why. Just give me 1.10 or sometimes like that. So this some part of the IPs are reserved. And the reason is 1.2 is the DHCP server for every subnet. Maybe we'll explain that maybe in the future session. So every subnet has its own DHCP server. You know, when you are creating a DHCP, a VPC, you are going to see something they call DHCP option. So each VPC has its own DHCP server, so that it will be able to resolve locally your VPC, your server host name, and all stuff like that. So this is just the IPv4 addressing in AWS, not the underlying IPv4 addressing. I believe most of us know the basic IPv4 addressing. So now let's go to a brainstorming session, and this is going to be engaging. I think I'm not going to talk for the next 10 minutes or 15 minutes. So I want each and every one of us to read this question very well. And I want approaches, I want suggestion, I just want some, I don't just like ideas. So I think who is going first? Let me just, or should I give you like 2-3 minutes to read the question very well?
Yes, sir.
Okay, all right. So I think let's just take like minutes to read the question. So we have less than 1 minute. That's less than 1 minute. Who is going first? Can everyone hear me? You might try to screenshot the question. Maybe you have it in your side or something. I'm not hearing any response. Take a question or
I believe we can hear you.
okay. Okay. So I think by 12:21, we'll be trying to get push. Um, okay, are we good to go?
Hello.
Hi.
Hello.
Hello, I can hear you.
Yeah, hello. So let me give it a try at this
Okay.
question. Yeah, my
Okay.
name is Abdul Malik. So from what I can see here, they are hosting all the application on a single server. So I think the first thing that should be done is you can divide these into three-tier applications, right? Since you have the React server, so the front end can be on the React server, that's on the first EC2 instance. The first EC2 can be on the public subnet, while for the back end can also be on an EC2 instance, but can be on the private subnet. And then for the PostgreSQL, you can decide to use an RDS that support Postgre. Then for the EC2 instance, you also have issues with they run out of memory. So you can deploy those that's the front end application in an ALB, application load and balancer in multiple ECs. And then you also use auto scaling. Since it runs out of memory, you can use the feature of use like memory as a okay, when it exceeds a certain memory, then it auto scales, and then you have more of those EC2 instances. When the memory goes down to a certain limit, it also scales down. And then so the multi-easy also takes care of the redundancy also. So I think that should be on the basic level. That should be pretty much what can be done. Yeah.
Okay. Thank you very much, Abdulmalik. That's a very insightful idea. So can you draw the architecture? Which tools do you use to draw architecture? Do you have an idea?
I don't know of any tools.
Okay, all right. So maybe we'll try to do that after this
Okay.
discussion. We'll try to do that. So there is Draw.io. I personally like Draw.io, Draw.io. So this most of the diagram I have on my slide, I use Draw.io to do that. So we can just try to do like a very short overview of that guy. So anyone who is trying next after the Malik. Anyone trying next? No penalties.
Hello?
Just hi.
Yeah, so I can only contribute on the part that the complaint on the load on the website. So I think using the Amazon cache Elastic Cache. So it's kind of reduces the load on the website and can improve the response time.
That was a very good suggestion as well. Elastic cache, okay. That's a memory database.
Yes, sir.
Okay. So you're talking about the memory parts of the design, right? Okay, so any other person is going next. Feel free. It's just brainstorming session, just to their ideas. I know most of us have worked on things like for, like normal architecture. Yeah. Okay, so because of time factor, so let me just try to explain it. So, this kind of question or this kind of scenario is like a customer pain points. So you need to be able to identify the point, the pain point of the customer. What is the customer need? So, and the first thing you need to be able to highlight, for example, now, you need to be able to highlight the part that there's a slow response during peak periods. I get it. A slow response during peak period, server crashes, and also they don't have a disaster recovery plan, and they have a kind of a consistent linear growth. You need to I underline the fact that what their infrastructure component is about, the Python, the Flag, the Postgres, and all of that. And you need to understand the fact that it's an EC2 instance, everything is running my application. So why am I bringing this kind of question in the cloud networking webinar? The something is that you need to have a bit of idea of how everything works all together, because that's going to give you a kind of an edge when you're working in a production environment. You need to understand how this talks to this talks to this. If you are someone on the side that, let me just do my work, you won't be able to understand a lot. You'll be limited. But if you have the mindset of, let me understand how does this guy works, how does this application talk to this guy? Okay, the database talks to the backend talks to the front end. So that will give you an overview. Okay, whenever there's an issue, you actually know what to do, what to do, how to do, and where specifically you should go. So that's why I'm doing this kind of a broad on an architect question, so that we'll all have the idea back from the front end to back end and end-to-end understanding. So the first one is that they are running on EC2 instance. So we don't know if they have a route. You need to put it, you need to put, let me just try to add this one, this person. So, as I was saying, you need to be able to understand it from end to end. So don't just like, okay, should I'm a network engineer, I'm just an application engineer. I don't know. I don't need to know how this thing works. I just do my own part. No. That's not actually a very good mindset. So in this scenario, you need to understand the architecture. Now let's start from the users. So they need a Route 53 because in an application, maybe www.soullist.com, you need to be hosted on Route 53. That's number one. They need like a DNS. Maybe they can buy it on Google, GoDaddy or Namecheap or anywhere. You need to host it. You now need to host it on Route 53. There's a way you can transfer your domain that you bought from GoDaddy to Route 53 to copy the name servers. So once they've done that, you can move ahead. Okay, there's an auto scaling. They are growing, so they need the load balancer. A load balancer where we have like a single point of entry to the application, and it will be able to redirect the calls to multiple servers so that they'll be able to auto scale. Maybe they can start with 2 servers when it's time. The company keeps growing. It increased to 4 based on maybe CPU utilization and memory utilization factor. So for the auto scaling, so they need a single point of entry, which is the load balancer. That works, right? That's fine. So disaster recovery, they need to be able to make sure they are highly available. So that will give us the concept, okay, you need to put them in different availability zone. They need to have AZ1 and AZ2. They need to be highly available. That will give us the concept of, okay, their servers need to be in different availability zone. I get my point. So also their application is running on single. So we've talked about that into scale. they need to take care of, okay, the availability zone. AZ1, AZ2, let's take it like that. The application, which is a Python flags. The Postgres is a managed service. We can use an AWS managed Postgres database, put it in highly available zone. And another thing is that memories, like backups. How do we keep our backup? Do we still keep it on Postgres database, or what do we do? So the best way to put backups is to push all of them to S3 buckets. Since S3 buckets can store any objects, videos. Do you know that most of Netflix videos, they are using S3 buckets? You can actually browse it. So yeah, yes, the recorded video will be shared as well. So you can browse it. Netflix videos, most of them are S3 bucket. So S3 bucket can typically store anything, name it, anything. So you can now push the backups to S3 buckets. So that have solved the part of the database, the memory, and stuff like that. And also for the deployment, you can use CI/CD pipeline to deploy it. Once there is a code, AWS software has their own code pipeline. So you just run it and you put it on the server. And that's all. You are not using kubernetes there, and using Microservices. It's just like a simple 3-tier application, like 3-tier architecture. Same way someone has just mentioned it earlier. Just 3-tier application. That's all. But as you as a network engineer, you really want to design this guy, give them the right IP, to give them the right connection, which subnet is going to be in the AZ1, AZ2, what access do you need to give the database, the security group, and something like that. So you will be the one to take care of all this. So you need to understand how all these components will work in hand in hand, like how the whole setup works. So future session will have real world use cases like this. Maybe want to manage like 10 VPC, how to use transit gateway, site-to-site VPN. We'll have something more of this very well. But this is just like an architecture session, just to give us an high level overview of the stuff. So this is a diagram. You can see this is a diagram. So internet, this is Route 53. So maybe your name servers you've taken from Namecheap, GoDaddy, or any of the domain registrar that you know. You put it on 53 www.solis.com. Put the name servers there. This is your load balancer. This load balancer, you're going to create a CNAME or an alias for it, your URL, you expose it, and automatically you can put your certificates here as well. So it makes everything easier for you. So you have so this is the part of the highly available. You can see that these guys are in 2 availability zone. So, and this is the auto scaling part of it. So you can auto scale based on capacity. You know, I explained earlier that Jumia on Black Friday they need to auto scale, or else their server will just crash. Maybe when they see that, okay, the percentage utilization we are seeing, maybe the CPU utilization or the traffic utilization, there's something they call the key performance indicators, KPI. Yes, you'll be able to say, okay, the memory, the SLI, service level indicators. Sorry, KPI is in my mind. That's one. So we have SLI, service level indicators. You have SLA, service level agreements, and all sorts of that. So service level indicators like memory, like refresh rates, like all those properties, you can just use it as a factor. So whenever the CPU memory is more than 80%, auto scale to 2 more servers. Something like your Kubernetes autoscaler and stuff like that. So we have your Postgres. Thank you. Someone mentioned Postgres. And ideally, you need to replicate your Postgres, because ideally it's reads and writes from a single database. So you now need to replicate. So you can do a synchronous replication or asynchronous replication. So that your database will be replicated in case your active went down, the standby will be able to take over the function. Not that you just have only one database and everything crash and that's the end. So that's how it works. And this is the S3 for the backups. Maybe you want to keep backups of your database or backups of some files or customer file. You can put it there. So resources, AWS Workshop. I'm going to share this slide so whereby you can go there. That's levels, so you'll be able to do anyone that you feel like comfortable with. And it's just that's a step-by-step guide. There's a free tier AWS access, like it gives you beyond 1 year access, but you can only access free trial, free services. So you can't use more than that. If you use more than that, I'm going to I'm going to bill you, and that bill, I don't know, is a little bit high. So please be careful when you're using AWS. You need to set your cost management and all sorts of that. So Skill Builder is just like a learning platform for AWS. So you can actually go there and take some classes there as well. I put some GitHub projects as well. I feel like it's very useful. So I actually believe in practical action. So I think what you do, it's you very forget, or you can be able to explain it and document your process. I would advise you to have a GitHub account. Each project you do, document them. I have a blog. I have a blog that I write to. So it's an AWS blog, something like, we have Medium and all of that. So this one is dev.to. So try to put your content outside there. Do a lab, document your lab, document your progress, document what you've done. If you have challenges, put it there. So that's really, we are all human beings, nobody's perfect. You have a blocker, you can reach out to me. And also just make sure you document your process. It's very, very good. It's going to be like a source of reference for you and in the nearest future, everywhere you are stopped. So documentation is very, very important. So workshop, AWS workshop, AWS free tier account to get started, the skill builder, all of these guys are free. All of these guys are free. So if you want to contact me, that's my phone number, that's my LinkedIn accounts. And I knew some people that are connected on LinkedIn. That's my mail. I'm also building a community of cloud network engineers. So it's a part I've actually go through, and relatively I have 1 or 2 experiences about it. So I believe just trying to grow the community. So I have a community where I'll be sharing some info, next upcoming sessions, and other stuff like that there as well. So and also I have a newsletter. I mean, some people start field survey. I sent they got some mail from us. So it's consequent as well. So if you have not joined this tutorial, you are not a subscriber, so you can you need to drop the link as well. You drop your mail that you want to use and just drop it on the chat here so that we'll be able to reach out to you in case we have any consequent sessions and webinar. So I think that's all for my end. So let me take off this amount of time. Do you have any question? Any question and answer time? Thank you. Do you have any questions? So in the process we are trying to do question, let me just draw.io. Let me show this draw.io. Why is it a little bit slow? So this is draw.io. So you can easily click on anything you want. So if you want to add more shape, you click on add more shape, you come here, you click on AWS or like that, like that. Just click them and apply. So you have your services here. Application services. I think I prefer this end thing because of the shape and the color. In general, maybe you want stuff. Users. Is your VPC. So your region. And engage, you can just slide it up. Your compute, your string instance, dragging. Got these arrays here. Maybe you have your load balancer. You have your load balancer here. And you can duplicate and so you can, it's something you can just try to just walk around with just there and be really glad. So you can just put up any architecture you want by yourself, and when you are done, you can save it, you export it in that picture format or any format you want. That's all. So I don't know if there's any question. Can everyone hear me?
Yes, sir.
Okay. I don't know. Do you have question? So I'll be sharing. We try to share this software link here. So you can just try.
Sorry, sir. I have a question, please.
Okay. Yeah, sure.
Hello, sir. Good
Yeah,
morning. Can you hear me?
yeah, good morning. Good morning. I can hear you.
Okay, sorry, I'm Adibola Ibon. So, sorry, I want to ask, is there a way, or probably do you have a material you can share as one can use, on AWS CLI or Terraform implementation rather? I'm not talking about that.
CLI information. I didn't get that very well.
No, no, I was asking
You
that.
mean
Do you have any
CLI?
recommendation for AWS CLI and Terraform implementation?
Okay, AWS CLI implementation, right? Is that what you mean?
Yes, sir.
So what do you
Actually,
mean
I'm
by
looking at.
CLI implementation? You know, CLI is just like, okay, maybe you want to run like, maybe you have your PowerShell, maybe you want to run commands, CLI
Yes.
commands to spin up AWS services. You get, instead of doing it, going to your console to create, to click and click and click. So the CLI part is just to write some commands so that you'll be able to spin up the server and do things. So I'm going to share the AWS CLI implementation on this page. So you can look through and check. So now if the CLI components is based on services, so if you check it, if there's anyone you have any questions, you don't ask, I'll be able to provide more clarity as well. Because I don't know the specific service we want to check. So we can just check the things link and any service you want CLI command for. So you'll be able to get it from there.
Yeah.
Um,
Okay.
okay.
Thank
All right. You're welcome. So do you have anyone with any question again?
Sorry, the link for survey is not working.
Okay, all right. She should be working actually. Check.
Okay. So,
Yes, yeah. All right. I think in the absence of no question, I think I'll be stop the recording. And okay, in the absence of no question, I think thank you everyone. It's a pleasure to meet you all. And uh we would like to see you in our future session and webinar as well. So I'm going to follow up on the group. I think just make sure you join the WhatsApp channel so we'll be able to reach out to you for our consequent session. Thank you very much and have a nice day.